In this video, we're just generally going to talk about the idea of VPNs, and I'm going to introduce you to VPNs as a whole. So I'm going to start off by talking a little bit about how a VPN works and what a VPN does for you. So the general overarching structure of a VPN is when you send a request, the request is going to go to the router typically, then the router is going to send it off to the destination sends back to the router sends back to you. Rather than having this sort of structure, what happens on a VPN is you send your data to the router then sends the data to a VPN server, the VPN server sends the data to the destination, and then it goes from the destination to the VPN to the router to you. What that does is it actually helps to hide who is sending the data. Because when the recipient receives the data, they see it coming from the VPN server rather than from you. So it helps to obscure an IP address from being displayed, which allows you to improve the privacy of your network connections because you aren't disclosing IP addresses, which helps to limit the identifiable information that's traced back to you. So that's one benefit of an of a VPN. The next benefit of a VPN is it allows you to be able to access components that exist on that same VPN network. So consider the idea of a business that has servers, right? If people are on site at the office and connected to the network, they can access those servers because they are on the same network as them. However, what happens when they're off of site, right? If they're working from home, for instance, as a lot of us have been doing lately, in those sort of situations, we don't want to just open those servers to the public. That's a bad idea generally because then anyone can connect to them, and that would be a little bit more concerning. So what we do instead is we put them all on a VPN. We put the people who are remote on a VPN, and we put the servers onto that same VPN. Now what happens is when we connect to the VPN, because everyone is connected to the VPN server can act like a router. It can route traffic to other things on that VPN network. So it allows us to be able to access resources that exist on that network as well. And that gives us a nice little benefit of being able to access stuff a little bit more securely than if it was just floating out there in the public internet space. Now, VPNs are also generally going to encrypt communication. So that's another benefit that they'll give you is that they will encrypt your communication so that generally it's harder for people to intercept the data. Now, I just want to note here quickly, there's a lot of VPN services lately that are giving these nebulous claims that, you can't compromise it at all. It's impossible. It's completely secured. It's going to keep you private and it's going to do everything for you. A lot of that is sort of overblown. So a VPN is going to encrypt your communications. It is going to keep you from exposing your IP address. However, it is not perfect. There are ways to compromise VPN connections. And a lot of them boil down to things like man-in-the-middle attacks. There are other things like the VPN endpoints could be compromised. And there are a lot of more ingenious vulnerabilities that have been found in VPN-type clients as well. So the main thing that I want to get across is that if you want to hide your IP address, or if you want to connect to entities that are off of your network, and if you want to get a little bit of encryption in your communications beyond the ones that typically exist like HTTPS and SSL, then a VPN could be a good option. Generally, from a commercial perspective, they're very smart to be able to connect to components that exist on other networks. If you're looking for something that's going to make you completely invincible on the network and make it so that you can never be hacked, a VPN is not the answer. The answer in that case would be to not go on the internet in the first place. So a VPN helps to improve your security posture, but it doesn't make it perfect. I just wanted to note that so you have a better idea of what a VPN really is truly doing. So how does a VPN actually achieve this sort of goal? So there's a few different ways that it achieves that goal. And let me just move this over so you could see the point there. Okay, so the ways that we can achieve that goal is through site-to-site VPNs or through remote access VPNs. So a site-to-site VPN is when data is encrypted from one VPN gateway to another. So like I said, you send data to this VPN server, and then the VPN server deals with it from there. So in a site-to-site, we're encrypting the data between us and that VPN server, and then it might bounce through like many other servers at some point. Some of them will bounce through multiple servers, some bounce through one server, but the main idea is that it's encrypted from the VPN gateway to the other. A remote access VPN is a secure communication that's made from an individual computer to a VPN router. And this is more close to what I was talking about with businesses, where if they have these sort of external people and they want them to be able to access resources, they can use a remote access VPN to achieve that. So they can connect up to this VPN router. The router then routes them into things inside of that network, and everything is happy from there. So that's the different types of VPNs that exist. And in addition to these different types of VPNs, there's different types of protocols that exist for VPNs. So there's a few ones that are common. The first one is point-to-point tunneling protocol, or PPTP. And this allows remote users to access their business networks in a secure fashion. So this is a very sort of business-focused protocol typically. It allows you to access entities that exist on a network, but it's generally considered to be relatively weak. This is not a great protocol, and there are some good improvements on it. One of those improvements is L2TP, or Layer 2 Tunneling Protocol. This is an enhanced version of PPTP. It's actually a hybrid of it and another one called Layer 2 Forwarding Protocol. And it's widely used by internet service providers that enable VPNs. It achieves a lot of the same goals as PPTP, but it does it in a more secure fashion. So it's basically just an improvement on PPTP, and it's the version that's a little bit more widely used. Now, in addition to this, we also have IPSEC, or IP security. This one actually runs on the IP stack. So the other ones were running on layer 2. These ones are running on the IP stack instead. So it's one layer up from where we are starting. And this is actually more of a suite of protocols and algorithms that can be expanded in a modular fashion. So we can sort of expand this as much as we need to. And it allows us to be able to encrypt the data securely on the IP stack. So it's just giving us further encryption on the IP stack to help to secure our data. And then the final sort of thing that we have is the SSL VPN, or Secure Socket Layer VPN. And this sort of provides two main things. So it provides a secure remote access via a web portal. So since we're using SSL, we're thinking web traffic, so we're working through web portals. It also allows for network level access via an SSL secure tunnel. So this is one of the more traditional ways of being able to encrypt our data through SSL. We create this tunnel, which is sort of just like a way of hiding our data under this encryption, allowing us to be able to send data to and from locations. And this is able to integrate with multiple authentication layer mechanisms. So we can use lots of different types of authentication with SSL VPN. So understanding these different protocols and the general ideas of VPN, you should now have a bit more of a solid understanding of what a VPN is and how it generally works. In the next video, we're going to go into a little bit more detail of a few more components of VPNs, and then we'll actually start working with OpenVPN to see how this sort of system works on Linux.